Our design project was with All-Clad Metal Crafters, a manufacturer of cookware based in Canonsburg, PA. The focus of our project was on the cladding process at All-Clad's facility. Cladding consists of heating, bonding, and blanking into discs. First, 3 metal sheets are stacked where they are then fed into a preheat oven for a designated amount of soak time. The heated metal then continues onto a milling station where it must pass through 2 mills before entering the post-heat oven for a final bake. At this point, the different metals should be bonded and ready for stamping into individual blanks. At All-Clad, metal packs were overheating in the preheating process, indicating a potential for cost reduction and increased throughput. With this in mind, we aim to reduce cost and increase throughput in the preheat process while ensuring the metal achieves the required bond quality. We plan to do this through a pack design improvement by increasing from a 3-out to a 4-out for certain blank sizes. Also, we plan to decrease the soak time, the time each pack of metal spends in the preheat oven, ultimately improving the process efficiency.
As shown in the graph here, 9-inch blanks being run through the oven at a soak time of 28 seconds were initially reaching an internal temperature of 765 degrees Fahrenheit when the company's specification is only 650 degrees Fahrenheit. The effects of this were shown in the appearance of the blanks after the cladding process, where the disc turned purple due to overheating. This coloration requires buffing to remove, leading to longer cycle times in downstream processes. We approached our project by first performing a baseline analysis on the current state factors of the cladding process. We then redesigned the construction of the metal packs to better utilize the material and increase throughput. Next, we established trial conditions for our data collection by changing the soak times associated with each blank size of the D4 product line, and then performed several trials according to these specifications. We incrementally reviewed the data collected after each trial and compiled all of our results into a final analysis and recommendation. To begin our assessment, we performed a cost analysis of the current state of each product in the D4 line to create a point of comparison for all our final results. This is a sample of the Excel sheet used to calculate the cost of the cladding process for each product, which changes based on factors such as soak time.
Our first initiative was to convert most of the products in the D4 line to a 4-out design rather than the current 3-out design. This means that the pack is elongated to allow 4 discs to be punched from each metal sheet, increasing throughput. We used an Excel sheet to determine the conditions of the trial and material needed. As seen here, the gray cells are auto-populated based on inputs for blank size, blank type, and shape. Calculations had to be made for all 3 layers of material in each pack, and to account for the new 4-out pack design. Similarly to the material, the oven conditions were calculated in a similar manner. Formulas used were representative of All-Clad's process for determining these metrics. There was also thought that went into data probe insertion position to ensure accurate temperature readings between the metal sheets. For our trials, we tested 4 different sized blanks in efforts to lower the internal temperature of the metal sheets. To accomplish this, we incrementally decreased soak time in the preheat oven, which we believed would decrease the internal temperature of the packs and increase throughput.
During our trials, we collected data on a multitude of factors such as internal pack temperature, resulting bond strength, quality issues, and subsequent worker tests. Our main constraint for this project was to ensure that the metal packs bonded adequately at a strength of at least 100 pounds force. Since this is a destructive examination, we tested 1 disc from each soak time in every trial to ensure quality throughout the preheat process changes. Our trials resulted in successful soak time decreases for all 4 sizes tested and 4-out pack design improvements for the pans capable of this additional length. We found that there was a limiting factor of 23 seconds for the cladding process because otherwise additional resources would be required to keep up with this pace as well as ensure a safe working environment.
Following the completion of our trials, we compared our results to the current throughput and cost calculations. In terms of throughput, for each blank size, we saw significant increases in how many discs could be made per hour. Simultaneously, we reduced cost by lowering the soak time, therefore decreasing cycle time. To allow for implementation of these new soak times at All-Clad, the team had to submit engineering change requests recommending these formal changes to the cladding process for approval. In the future, there are still areas of improvement available at All-Clad. For one, The remainder of the D4 product line could be tested to find optimal soak times. Additionally, by speeding up the oven process, we created a new bottleneck at the deburr station where further investigation could occur to combat the stacking of blank. We want to thank All-Clad for hosting us this semester. Additionally, we would like to thank Catalyst Connection and Dr. Lancasorn for their support during this project.